All right, hello everybody. My name's Steve Kinney. I'm the application engineer here at Prinostat for our 3D scanning services. I just wanted to give everybody an introduction to 3D laser scanning here. I'll start with a quick introduction to Prinostat. Prinostat was founded in 1954 as a blueprinting service. In the late 70s, we added a surveying division that takes care of, and even today we still do sales and service of surveying equipment, including our geospatial solutions, which involves 3D laser scanning. What is 3D laser scanning and how does it work? The 3D laser scanner is a line of sight device. It uses a laser. It emits a laser signal that hits a surface. Part of that signal refracts away from the surface. Part of it reflects back to the machine. Now the machine's recording its horizontal and vertical position and the amount of time it takes for that signal to return to the unit. And using these measurements, it's able to calculate an XYZ coordinate for a single point. Additionally, the laser scanning unit takes color photography after it's done scanning. On the left side of this image, you can see the color photo overlaid on the point cloud here. In the middle and the right side, we also have two additional viewing options for the point cloud. This is what it would look like if you were to take a scan without the photography. And what it's doing here is it's using the amount of light that reflects back into the unit to colorize the gradient you see there. So darker colors that absorb more light or shinier surfaces that reflect away more of the laser signal will be a darker red or a black, and surfaces that reflect more light back into the unit will be either a bluer or a whiter color. The scanning hardware we use is all Leica equipment. We're an authorized Leica reseller for Leica 3D laser scanners. Primarily what I use is the new RTC 360 unit. Here are just a few pictures of what the unit looks like out in the field. It's pretty small, it's battery powered, it's completely self-contained. It's very easy to maneuver around complicated equipment, and the whole thing folds up into this small carrying case, and you can see the collapsible tripod there as well. So it's very versatile equipment. It's not a big clunky unit, very easy to get in and out of tight spaces with. Here are some basic specs for the accuracy of this is actually the RTC's official specs here. But basically what you can take from this is that any point cloud you scan is going to be usually within 3 millimeters of accuracy. So that's the kind of precision and accuracy you can expect from a 3D laser scan. The range for any individual shot is up to 300 or about 420 feet. So even if you're in large buildings, multi-story mezzanines, things like that, a single shot is more than enough to capture everything within visible range. The RTC 360 shoots 2 million points every second it's running. And the pictures only take a minute. So each individual setup is around a minute and a half to 3 minutes, depending on settings. Now, the image we're seeing on the right here is a close-up of a point cloud, and you can see that the point cloud is made up of millions and millions of individual points in 3D space. Over to the left, I have a few of our settings from the scanner, and that's showing you the spacing of each of those points from each other at a fixed distance. So 10 meters away on a medium setting, you're looking at 0.23 inches of space between each discrete point. Laser scanning is very versatile technology. We've used it in a number of different industries. Here's an example of 3D laser scanning being used for large-scale land surveying. This can be used for topo maps. It can be used for volume calculations of materials, things of that nature. Civil engineering industry also uses laser scanning. This scan was done to monitor erosion of the creek bed there. It's also very nice to get hard to reach spots like the underside of that bridge. It would be very difficult to physically get up under there. But with the laser scanning, you can scan it all from a distance safely. Historical restoration and renovations. The density of points that you gather is really great for capturing all the detail on a lot of this trim work and things like this. Architecture. It's a very quick way to go through large-scale buildings and get accurate plans. A lot of older buildings we encounter have either no plans at all or very outdated plans that are inaccurate. Construction, both new construction and renovation work. Again, you're dealing with buildings with outdated plans, or being able to check the site work with the intended design is pretty useful. And of course, mechanical, electrical, plumbing, which is what we're mostly going to be talking about today. Rooms like this, where there's tons and tons of pipe runs and ductwork everywhere, the laser scanner does a great job of picking up all of those pipe diameters, where those pipe runs are going very quickly and very comprehensively. So the scanning workflow, excuse me, can be broken down into 3 stages. The first stage is data collection, obviously, going on site, doing the scan work itself, taking those photos, setting up targets if you're putting the point cloud on survey control, things like that. Then we move over to the processing side. The first bullet point here is called cloud registration. This is the process of taking all the individual scans we've done out in the field and stitching them together like putting together a large jigsaw puzzle. The machine uses overlapping data to stitch together a complete point cloud. Then we can go through and clean up the data. If there are people walking around, if there are cars driving by, that all creates noise in the point cloud. We can go through and then eliminate all of the unwanted data that was captured. Then we move over to the post-processing, which is taking the complete point cloud and then from that creating models, 2D drawings, new design, clash detection, things of that nature. And that's more what the Hershey guys are going to be talking about here is the post-processing. This is an example of a single scan. This is what one scan looks like from the perspective of the scanner. So you can imagine the scanner was sitting and it shot its laser and it collected everything that was within that line of sight. And looking at this image, it looks very comprehensive. We've got data on the ceiling. We've got data on all the column lines. Now, if I take that same scan and I move it to a different angle, you can see all the data that's actually missing from this shot. So I'll go back and forth a few times. You can see anywhere that there would have been a shadow cast by that laser, we didn't get any information. So that's kind of how the line of sight laser scanner works. Now I'll take a look at that same shot from a plan view. So in the top left corner, you can see that's where the scanner was sitting. This is a plan view of the room, and you can see where all of the column lines left shadows and missing data. Now what I'm going to do is I'm going to go down to the bottom right, the opposite corner of the room, and take another scan and stitch that in. You can kind of see how by adding another scan from a different angle, we can start to fill in a lot of that missing data. Now, a building like this, I would probably typically do 60, 70, even 80 shots. And when you fill all that in, you can see it fills in a lot more of the detail. So by taking all of those individual scans and stitching them together, we get a much more complete image of the environment. And here's a 3D view of what that building looked like when it was finished. So I went through the entire floor, the basement level, and the entire outside of the building. And here's just a quick video to show you what a point cloud in a manufacturing environment might look like. All of these shots were taken from the ground level. So once you have your scan collected, you can navigate through it in 3D space however you like. Even if the scanner was sitting on the ground the entire time, we still are able to go up into the ceiling here. We're able to get all the pipe runs along the walls, up at the top of the room. It's very versatile. Once you have that data into your computer, you can do pretty much whatever you want with it. And with that, I will hand it over to the guys from Hershey to talk about the next phase.
Okay, can you guys hear us?
Great. Welcome to the second part of our presentation on using 3D laser scanning to gather existing conditions in a manufacturing environment. As Steve said, we're going to focus on the post-processing aspect of 3D laser scanning. This is our agenda. We're going to have an introduction of the presenters and what we do at Hershey. We're also going to talk about how we identify projects that we're going to 3D scan. We're going to talk about our scanning specification, how we use the data, and also our design workflow in CAD software and how we complete our design throughout the project, and then questions and contact information at the end. My name is Warren Miller. I'm a senior CAD specialist at the Hershey Company. I have worked here for 6 years. I specialize in process and instrumentation diagrams, or P&IDs, and piping design, primarily in the 3D environment. I also split responsibilities with Chris for general CAD management, and also we support AutoCAD software throughout the entire Hershey Company.
So my name is Chris Richter. I also am a senior CAD specialist at the Hershey Company. I've been with Hershey for about 5 years. And like Warren, we specialize in equipment and architectural, structural design. I don't do as much piping as Warren, but a little bit of like project coordination work, things like that. And like you mentioned, we manage the Autodesk software and provide support to all of our users across the entire company. So our department is made up of several full-time design engineers, as well as the CAD administrators, which is what we refer to as CAD Support, which includes Warren and myself. Our team basically works between our corporate engineering team, our plant engineering partners, our external equipment vendors, and A&E partners to develop a design solution for our projects and manufacturing facilities. So we usually are involved in the concept development at the early phase of a project. We help the engineering teams and external vendors select and approve equipment based on what will fit in the space and what is it's going to be replacing or anything like that. We're responsible for the design coordination, making sure that everything fits in the space, and we're coordinating everything with the external partners. If there's a mechanical engineering firm we're working with, or if we're doing the design of the piping and the process system. And as well as developing construction documents for construction or installation. So having the drawings that the contractors need in the field to get everything installed correctly. And at the end of the project, we go through and we as-built everything so we can maintain an updated set of architectural and equipment layouts for our facilities, as well as archive all of the engineering documents involved with each project. So the next section here is some things that we use to identify which projects are appropriate to be scanned. Not every project we do is really a candidate for 3D scanning, but we have a few simple criteria that help us determine if it's worth to have it scanned or not. So here's a kind of a brief checklist of items that we typically look for from a manufacturer for projects that we think might be eligible for 3D scanning. So if the project has a really short timeline or lead time, then obviously the work you do up front has to be done quickly and has to be correct. So scanning can often be completed in a single day. So Steve has done a bunch of jobs for us where he's come out and he's scanned an enormous area in less than 8 hours, and then he turns around the files for us in a couple days. So within, the phone call to Steve telling him we have a job and having the completed files back to us, usually that happens within a week. I don't want to put Steve in a pinch or throw him under the bus there, but he's pretty fast. If it's a complex area, so if there's a lot of overhead piping or ductwork or conduit or existing equipment, if it's just a really tight space, and we're concerned if the new equipment is going to fit or how we're going to get it into the space, say if there's a rigging path through the facility, we have to consider, obviously the scan helps us with that. We don't really forget to take any dimensions because the scan captures it all. If there's space constraints, like I mentioned, if we're not sure if the new piece is going to fit in there, we want to confirm that. We want to see what maybe has to be modified in the field to make that happen. This can help us determine everything that we're going to need to communicate to the contractor for installation. If it's a remote facility, it allows us to save on travel costs and return visits. So by deploying a 3D scanning team out there, they can perform the scan in often 1 or 2 days and return, give us the data. We could all sit in our office or nowadays at home and complete design work from behind a computer, and we won't have to be out in the field or going back on site or flying across the country to get to the facility for if we missed some dimensions or if something else became in the scope that we didn't capture on our first trip. Usually the scan captures all of that. If there's a lack of information about the facility, so if it's a facility that you have either recently acquired or that you're not really confident in the level of accuracy of the drawings that exist for it, then the scan will obviously fill in those missing pieces and give you the most accurate representation of what that facility is like today. And lastly, if the final design for the project is going to be performed in 3D, which many of our projects are nowadays, the 3D scan really helps serve as a background reference. So we'll get into some details later in the presentation where we're able to load this 3D scan file into our design applications and check it basically in real time against our proposed design to see how it fits, determine the best pipe routing, things like that, what has to change, what has to be demolished, that kind of thing. So it really helps us complete the design and come full circle on it. So from a manufacturing perspective, we see several benefits that you might see as well if you've ever used 3D scanning. So first jumps out to us is people safety. So one of Steve's photos showed the scanner sitting on a tripod with the technician standing next to it. He mentioned that it has a range of, I think it was 120 meters. I believe, or something like that. It's farther than you're going to need in a manufacturing facility. So this information can be captured from a distance, and you're not going to have to put it up on a ladder or a lift or anything like that, or any scaffolding or anything. A lot of this can be captured from the ground or existing platforms to give you enough information that you need for your design. It's great for food safety. Nothing touches anything. The scanner operates without any contact for product surface areas. It doesn't touch, the floor. It doesn't really do anything like that. So the only thing that's touching anything is the scanning operator touching the doorknob, walking into the plant and wheeling his tripod around the floor. So a lot of this can be performed away from product operations and product traffic flow aisles. So you can keep, the scanning technician safe. You're not impeding production by any way, really. It's kind of happening behind the scenes while you're out there, and you can't see it, silent. It's it captures everything without really being disruptive at all. It's great. as well as there's free viewers available for this software. So recap in a couple minutes. And that's one of the tools that we usually share with our engineering partners or plant personnel to get them involved with the data. And if we scan a certain area and they're involved with the project, we usually give them the scan file and set them up with the tools that they need to use that information. That way we're getting the most value out of it. So from a project perspective, since most of us on our design team work on projects often, one of the things that we like about it is the level of speed and accuracy that we receive from these files. So you're able to capture the as-built conditions, either existing conditions before construction or as-built conditions afterwards, to an insane level of detail, more than we really need. But it's there when you need it, and you can be very precise. It's also much faster and more precise than traditional methods of field surveying, like using a tape measure or a handheld laser and a notepad and pictures on your on a camera or your phone. It really that process takes a while. You're touching things with a tape measure. You have someone out there on a lift. You're walking around a production area. You have extra people. You can see where this is going. The more people you can get out of that area, the better. So it's very economical. So as we mentioned before, you can reduce return trips and travel costs for additional team members. In the time that it takes for Steve to go out there once and scan everything and come back, it could take several days for one of us to go out there and capture a quarter of that information, let alone return trips if something else comes within scope or if we realize that there's something that we missed. So the travel time saved really helps us for sure, and especially these days with traveling. So and as well as common file types, so we can share the scan data in several different formats with our external equipment vendors if that's something that they have either requested or can use, or our external architectural and engineering partners. So if we're working with an architect to do an expansion, I mean, we can share the point cloud scan with them that they can use to confirm the existing conditions or as-built conditions of the space. So, and these file types are recognized by most common industry design software. So Hershey uses the Autodesk suite or Autodesk tools primarily, and these files work flawlessly with that software. So that allows us to work, very easily with this data. So the next section here is about developing a scanning specification. So when we first got into 3D scanning, we were still learning about it. We had a few scans performed. We started getting the data back and realized that there were some things that would make it easier from our perspective on how to use the data and how to transfer things. So in keeping with other specifications that we have for our manufacturing facilities and design work, we developed a scanning specification that's helped us keep our file deliverables for this type of work standard, and lay out the ground rules for scanning procedures in our facilities. So it also helps us simplify the communication between teams within Hershey and outside either scanning partners or an architectural firm. So sometimes we have there's project managers or people from the plant that will request a 3D scan, and this document that we have will allow them to give the correct technical information out to the scanning partner, and so we get a file back that we need. Because once the data is registered and it's sent over to us, I mean, if it's done a certain way, it's a lot easier for us to use. If it's done differently or the files are too big or anything like that, it becomes cumbersome to work with. So the scanning specification helps us get what we need and helps give our scanning partner better expectations on what they're getting into for that job. So some examples that you can have included in this is the data capture and the scanning method. So you can mention anything you want here about your facilities. If they're going to be required to wear PPE, which at all of our facilities, that's the requirement. What the file properties are, so the file types that you're hoping to receive from the scan, the file sizes, if you want it broken down into segments that are easier to work with or easier to transmit, that your scanning partner can do that as well. The point density, so the level of accuracy you want, or Steve mentioned that this equipment can really get very precise, and as you would imagine, more points is a bigger file. So if you're scanning a larger area, maybe it's outside, you might not need the amount of density or information, I guess, in the file that you would in a very complex, tight area where you need the precision that counts. If you want your scan to be completed in color or black and white, we typically prefer color just because of the way that we review this scan with other people. Black and white works all the same with the software. It's just personally, I think that the color is easier to work with within these tools, and it's easier to review with people from outside of the design group that, you know, it just helps them see the space and understand what's going on there easier. As well as units, if you guys typically work in imperial units like inches or metric units. Defining an origin point and how the scan is aligned within the file is also important if you're planning on loading it into design tools. So that's something that we've worked out, and kind of we like to align it like with a column grid line or something like that, or a corner of a room. It's just easier to get the scan into a building model on our end if there's a meaningful origin point. But you can also do that by GPS or things like that, whatever your standard is. And you also want to communicate what areas are within scope or what area that your scanning partner should focus on. So if you're really only concerned with capturing the architectural envelope of the room, if you're doing an office area or something like that, and you're not really concerned with anything above like a drop ceiling, or if you're looking to do something out in your manufacturing facility where you really want to catch all the equipment, all the overhead piping and conduit and things like that, you want to have a comprehensive representation of the area, then you'll want to let your scanning partner know so they know what to expect and they know what level of detail they're going to need to capture in the field. And lastly, the file transfer method. So these files are rather large, and if you're planning on transferring them from your scanning partner's office to your office, you're going to need a plan to get those files back and forth. You can't simply email them. So we usually try to use OneDrive within Hershey. I know some people use Dropbox. But lately, with these files being so large, we've really been sharing them with external hard drives. That's been our method. That's been preferred lately. So I'll turn it over here to Warren, and he'll take you to the next section.
So the next topic is using the data, how we receive, use, and store the data long term. Just as Chris mentioned with the scanning specification, it's a good idea to make a plan on what you're going to do with the data. So obviously the first step is how you're going to receive the data. These files are very large. It depends on how big of an area you're scanning, but typically we've been seeing between 20 and up to 200 gigabytes for the complete scan package that we request through our specification. Many companies, as well as cloud services, have limits on single file size. For Hershey, we use OneDrive, and that's 13 gigabytes. That may vary. It's also important to think about downloading the files. You know, at this time, with a lot of people working from home, you have to consider network speeds and how long it might take you to download that file from a cloud service. At Hershey, we've been using swapping of external, USB hard drives as a quicker method that we can get the data directly from Steve and then just copy it onto our hard drives and copy it into other places that we need to. That's a little quicker than downloading it from the cloud. And once you receive that data, then you have to think about, okay, now how am I going to store that for the long term? As we talked about, they're very large files, and at Hershey, we've been scanning for about 4 years. And we've accumulated 3 to 4 terabytes of data. So that's a big thing to think about, is how you want to keep that data secure so you can use it over and over. Our method is to use virtual network servers. We currently have 2 of them. They're like in the Hershey system, they get backed up. So it's a secure place to keep those scans. And then when we need them, we can send them out to other vendors or copy them or what have you. And then the last is how you will use the data. So when we're working on a project, we're working with the scan in our design. It has worked best to have that locally. on our hard drives, on our laptop hard drives. So that's also another point to consider, is how much space you have on your hard drives, and maybe you're looking to get new computers or new laptops at this time, for people working from home. So that's something, to have an extra 100 gigabytes on your laptop hard drive to put a scan that you're going to use. When we're just reviewing the scan, so looking at them in recap or just doing a quick look, we found that we can access these scans through our virtual network servers, and the performance is acceptable. There's some other solutions. There's some cloud-based viewers that Steve could help you with. They include like Jetstream and some others. And that's it for that section. The next topic is how we use the scans in our design software, such as AutoCAD, Revit, Navisworks, etc. When we're starting a project, this is like our overall workflow on the software we use, and then also when we determine when we may scan the project, if it fits the checklist that Chris talked about earlier. So during the preliminary design, we're just kind of working on, ideas and possibilities. So we're using AutoCAD, we're using Plant 3D, we're using Revit, just get like basic ideas on paper. Once those ideas, become final, and then the project goes through the Hershey approval process, at that point, that's when we would typically scan the existing conditions so we can have that to do our complete final design. During the design development, that's when we're going to be using that scan we captured inside of our design tools such as AutoCAD, Plant 3D, Revit. And at the same time, we're doing design coordination maybe with external vendors that are doing parts of the project. And we're using Navisworks to bring in all of our models and the scan together to verify the design. And then once the design is finalized or good enough for bid documents, then we will finalize those 2D drawings that we're going to send to contractors in our design tools. Once the bid and the construction documents are out, we will transition to the execution phase, which is the construction and installation of the project. During that time, we primarily focus on using Navisworks to, maybe look at problem areas or come up with, answer questions about specific detailed areas of the project, and that can be coordinated with our models and with the scan. And then the final step would be the project closeout, and in the perfect world, we would scan this project again to capture all the as-built conditions, so we have that going forward for when the next project comes into that area, and hopefully nothing has changed, and then we can use that scan again and reap the benefits of it. So the design workflow in AutoCAD, and this includes AutoCAD verticals such as architecture and the software we use a lot at Hershey, Plant 3D. You can attach a recap RCP or RCS file directly into AutoCAD, just like you can a normal external reference DWG drawing. When you bring in like an architectural background or something like that. There's quite a bit of built-in tools in AutoCAD to work with scans. This includes a tool where you can set a section plane through the scan, and AutoCAD will generate lines from the points that are collinear and have the same location. And this allows you to get like a rough cross-section of any level in the scan. You can also find edges and corners using planes of the scan, so AutoCAD can like find where a bunch of points make up a plane, and it'll actually snap to that, and then you can find two of them and it'll make an edge, or you can find three and it'll make a corner. One of the tools that I use a lot in my piping design is you can find center lines of any cylinder. And, as you know, pipes are cylinders, so that allows us to model existing piping that we may be tying into or that we have to route around, and it's very useful. There's also a bunch of snaps made specifically for scans, and that includes the nearest plane, which you could use to align, your walls or some other equipment to the scan. And then you can also even snap to individual points. How we use the tools in AutoCAD. So our workflow is we generate the lines from a cross section, and then we use those lines and the scan to align it to our, 3D or to our existing 2D CAD plans in our existing coordinate system that we use, for all of our projects in that facility. Once you have the scan aligned to the walls or columns or something like that of your 2D plan, then you can update other 2D geometry to match actually the real world conditions. If your plan isn't as up to date, or maybe you don't even have a plan, you need to draw that 2D geometry in there. And then we also use the scan as a reference to generate 3D geometry using, the standard extrude and plant 3D piping tools that are already existing in AutoCAD. And then at the bottom, you can see this is the ribbon that comes up when you have a scan selected. So you can see, you can, control the size of the points, the level of detail. You can also control the color. So as Steve talked about, you can go to that intensity view. You can also go to black and white. And then there's some other tools in that ribbon. These are some screenshots of a scan that Steve did in Plant 3D AutoCAD. The picture on the left, you can kind of see there's some green that's coming through the scan. That is those cross-section lines that AutoCAD generated. And then on the right, you can just see a little bit different view of that scan. And it's important to know in that view on the right that the room kind of to the back left was not a focus point of the scan. So that's kind of why the data looks a little sparse. It was just captured through some windows and some open doors. The focus of the scan was to the lower right. You can see there's a lot of detail and it looks really good. Our design flow, workflow within Revit. So just like AutoCAD, you can link in the point cloud to your project file or your model. You can move that cloud around to align with an origin point or an existing model. The point cloud is visible in plan, section, 3D views. It's visible throughout the entire Revit workflow. And then some tips to work with the scans in Revit. It's a good idea to load and unload for performance. So if you're not using the scan, it's a good idea to unload it so then your model performs as normal. And then also turn on and off the point cloud snaps because it can be cumbersome to have it try to snap to a bunch of points when you're trying to snap to maybe, a wall or some of your existing geometry. And then you can also see on the insert ribbon in Revit is the point cloud tool is selected in blue, kind of to the right side. That's the tool you would use to bring in the point cloud into Revit. Our workflow in Navis. So Navis is one of the tools that we use the scans in, I would think, the most. You can add, the recap RCP, RCS files, just like Revit, just like AutoCAD, into Navisworks. You can align them, using your coordinates that you got from AutoCAD. This allows us to coordinate our 3D models and our scans together, and it performs really well. Performs a lot better than your AutoCAD and your Revit, just because that's what Navisworks was made for, is to coordinate. It can bring in up to 50, about 50 different file types. You can fly through the scan and design models together in one software, so you can really dig into the details and make sure your design, your project, your equipment is going to fit into the space that you have scanned. You can also use the clash detection tools within Navisworks to run clash detection between your models and the scan. So we have some screenshots. The picture on the left is a scan with our model inside of it. So the model is the green, the pink, the orange. So this was some tanks and some piping and a platform that's going to fit in this space. You can also kind of see we modeled some existing piping in a darker brown in the center of the picture. So you can kind of see the scan wrapping up around that pipe. because we were able, because the scan's so accurate, we were able to model that, exactly how it is in the field. And then the picture on the right is an example of the clash detection between a scan and a model. The model is the elements in green, and the scan, the points, are the elements in red. Then the final software that we use is Recap and Recap Pro. This is a software that we use to view the scans and also the 3D pictures that Steve talked about that the scanner captures. This software is available as a free download. We have the link here in the presentation. It starts as a trial, a 30-day trial of Recap Pro, and then it would transition to the free version of just Recap, where you can just view scans that that Steve creates. The Pro version is a paid version. It has some additional tools that the standard Recap version doesn't have. Some of the tools in the Recap version is Limit Box, so this allows you to suck in a box, into an area, maybe bring the top down below the roof so you can see all the equipment in that area. This allows you to look at certain areas in detail and also, cut out some areas that maybe you don't need to see at that time. The mirror balls, so that's a term that Recap, you can see in the picture on the left, you can see the little, orb-looking balls. Those are mirror balls. So that is all the locations where Steve has scanned, where the scanner was set up and he ran a scan. So you can click on those mirror balls, and then you can go into the 3D pictures. You can also use Recap to measure very accurately, the same accuracy that Steve talked about. That can be completed in the 3D view, which is just the view of all the points, and also in the real view, which is the view with the panoramic pictures. In the Pro version of Recap, you can actually work with the raw scan data, so you can register and combine multiple scans together, like Steve talked about, to make one larger scan file. And then, as I mentioned, the picture on the left is a scan in Recap. You can see the mirror balls. I also had a mirror ball selected, and you kind of see it brings up a preview of the pictures in that area in the top center of the screen. And then the screenshot on the right is actually going into that mirror ball and looking at the 3D pictures. And you can see this is, all but real world. I mean, it is very clear. All the colors look great. It's very accurate. And then you can rotate around and look, 360 up as well as above you, and you can take measurements, and you can just look through the scan. And then, if anybody has any questions, I know there's going to be a live portion of this, but we also have our contact email, which is cadsupport@hersheys.com. And that's it.